Okay, today we have another simple but totally new idea, something I don't think you've ever seen before. So I would, go slow, pay close attention to what's going on here, take good notes because it is a new idea. And that idea is called radians. That should be a totally new word to you in every way. Okay, so let's and just by looking at the first question here, it says convert 120 degrees to radians. Just by reading that, you should know that that means that radians is another way of describing angles. Because we all know degrees is a way of describing angles, and we're supposed to be able to convert these degrees to a new way of describing it. And so let's not do this problem yet, kind of like I did in the last lesson. I just wanted to show you where we're headed first, but not actually do that problem. I wanted to set something up here. And the number one thing, let's just start with this. Let's start with a unit circle, or a circle again, that we were talking about before. We all know this is 360. Okay, this is 360 degrees. When we go around, when we start over here, and we go around one time, it's 360 degrees. Well, the other way to describe that, and the conversion for radians in degrees, is that 360 is going to be the same as 2 pi. 2 pi, 360 degrees is 2 pi radians. And as we keep moving along, you'll kind of see why this was invented. And don't forget, it's just invented. It's just something that somebody came up with. So don't overthink it. But whenever we want to convert from degrees to radians, this is one of our conversions. Or another conversion would be that 180 degrees must be then pi radians. That's also always going to be true. Because, half a circle, this is a full circle, this is half a circle. This represents a full circle in radians, so this is half that. 1 pi, 2 pi, 1 pi. Now for the question, let's get to the question that we're being asked, 120 degrees to radians. So there's different ways to do this. I like doing it this way. 120 goes with, I don't know how many radians, but I do know that, let's say, 180 degrees goes with pi. I pick something I know that goes together. So it's just a simple proportion. And we don't really even need to put the degree symbols in here. We're just going to cross multiply here. But notice I have what I do know, what I want to know, and then I found another one where I do know and I do know. So I know 3 of these things. I know that this goes with this. I could have wrote 360 here and 2 pi here, and everything would have been fine, but that's just bigger numbers for no reason. So I like this one's one of my favorite, probably my favorite conversion factor for radians and degrees. So we get 180x equals 120 pi. Just cross multiplying. 180x times x equals 120 times pi. And then to solve this, we divide by 180. And then the part that's going to mess with some of you guys is you can't just leave it like that. You have to reduce that fraction. So pretty easy to know that 120 over 180 is just 12 over 18. But then 12 and 18 are both divisible by 6. So you actually get 2 pi over 3. And those are the kind of answers you're going to see for radians. They're going to be a lot of fractions with a little pi hooked to them. Because it all comes down to, if you go back up here, it all comes back to that their 360 is 2 pi. So every radian measure is going to have some sort of form of pi in it. In fact, if you think about it, 120, let's just make a little more sense of this before. We'll go a little faster on the other ones, but I want you to understand what's going on here. 120 is a third of a circle, because it takes 120, 120, and 120 to get 360. So this was a third of a circle, a third of 360. Well, then this better be a third of 2 pi, because this is a whole circle 2 pi, and this is a third. Well, if I triple this, I get 6/3, right? Instead of 2/3, I get 4/3, 6/3, and 6 over 3 would be 2, which is 2 pi. So they will make sense. Once you do a few of these in practice, it'll make sense what's going on, as long as you can just understand this one thing right here. Or, I guess, this one too. All right, let's see what else we got here. This is the other way around. So now we're going to convert, we're going to go a little faster. We're going to convert from radians to degrees. So same idea. We're going to go 25 pi over 6, and that goes with something that I don't know. But I do know that pi goes with 180. So look, radians goes with some amount of degrees, just like these radians go with that amount of degrees. So we end up with pi times x equals, and this is where you might want to get a calculator out. It's probably going to be easier that way, because you're going to need to multiply this together. So on my calculator, I just did 180 times 25 and then divided that number by 6. So it was 4,500 divided by 6, which was 750 pi. But then what's going to happen on all these is you're going to end up dividing by the pi, which is what gets you your degrees back. So if you divide by pi, both sides, you just get 750 degrees. That's the answer to the problem. And if you think about it, so 750 is actually a couple times around the circle, right? I'm gonna do this one more time just so we understand. So 360, and then another 360 would be 720, but it's actually 750. So it would be like in there somewhere, which is not what you have to do on this problem. We're done with the problem. This was the answer. But I want you to understand that 25 over 6 is a little more than 4 pi, because 6 goes into 25 4 times with a little bit left over. Well, every 2 pi is 1 time around the circle. Remember, 2 pi is 360. So this is a little more than 4 pi. So once again, 1, 2, and then a little bit more. Like I said, if you want to think about that for a little bit, but understanding it is probably going to help you retain how to do these problems. Next thing on the homework for today is finding the arc length. So we'll do this by also drawing a picture so we understand what's happening here. Find the length of an arc, and this is geometry review, by the way, where except for the pi part, except for the radians. You've never done radians, but the idea is the same. All right, a little technical difficulty there, but here we go. So we're going to find the length of an arc where r is 10 and theta is 7 pi over 4. So here's a circle. Maybe not a great one, but we'll try. Not terrible. I want you to see what's going on here. And then r is 10, meaning the radius of the circle is 10. And theta, this is where some of you might have a little trouble early trying to draw the picture, but it says that the angle is going to be 7 pi over 4. Well, 7 pi over 4 is almost 8 pi over 4, which would be 2. If this was an 8, this would be 2 pi, which would be the whole circle. So it's almost the whole circle. So it's kind of like something like, let's see, it probably look something like this. And this is the part of this, we're looking for this right here. Read the question again. It says find the length of an arc. So the arc is the length around the circle. How much of it? This much angle of it. How big is the circle? Radius 10. So the way we do these ones is we just find the whole circumference of a circle. We're going to start by finding the length around the whole circle. which is called circumference. Circumference formula is 2 pi r. I don't like that pi. So that circumference here is 2 pi times 10, which is 20 pi. And then all we're going to do now is, if we know the whole length, we're going to take the whole length, which we know goes with, that goes with 2 pi, and we want to find what length goes with 7 pi over 4. Let me explain this again. Once again, you've got the whole length of the circle, which was the circumference right here. And the amount of radians that goes with an entire circle is 2 pi, because it's 360 degrees. Remember, 2 pi is 360. And the reason I'm putting it in radians, not 360 here, is because they gave me the other angle in radians. So I'm trying to go length, angle, length, angle. So it's going to be 2 pi x equals, and then you want to get your calculator out again. It's going to be 140 pi squared over 4, which is 35 pi squared. And then we're going to divide by 2 pi. So we're going to get something like 17.5 pi, which makes total sense to the answer to this problem. And the reason it makes total sense is because the entire circumference was 20 pi. That's not that far off of that. And it shouldn't be that far off of that, because it was almost the whole circle. Why was it almost the whole circle? Because the radian measure that they gave us was 7 pi over 4, which is almost 2 pi. 8 pi over 4 would be 2 pi. So all this, if you think about it, really take the time to think about it, will make sense to you. One more. Same thing, only with degrees, which for some of you might just seem easier because it's not, radians is still a little new. But we're still doing the same thing. Find the length of the arc, same, I think that's even same radius, but a new amount of degrees. So the circumference of the whole circle is still 2 pi times 10, which is 20 pi. And 20 pi, which is the whole circle, goes with 360 degrees, which is also the whole circle. Remember, this is representing a length, and this is just representing the degrees around the circle. And then we want to know what length goes with that amount of degrees. So we set up what's called a proportion, right? So we now have that length goes with degrees, length goes with degrees. So that's going to be 360x equals, calculator, to 27, I don't need it, 2700 pi. And then now take 2700 and divide it by 360. And you get x equals 7.5 pi. Let's think about that one, and we'll call it a day here. This is it. This video, this is the only new things in the lesson. I think these are enough examples to get you going, but let's think about this. The whole length around the circle is 20 pi. 135 is a fairly small portion of that. Compared to 360, 135, quickly calculating is about a third. It's actually a little less than that, but it's around a third of it. And so 20 divided by 3, down here, that looks pretty close, right? That makes sense. Let's put it that way. It makes sense that this length compared to that length is related to this degrees compared to the full amount of degrees. Well, that's good enough. Let's work on the homework now. All the examples in the homework, or all the problems in the homework, are much like these examples here. So work hard, be nice, and see you soon.